Hey guys, today we're going to be focusing on our first big objective in our first unit, which is on temperature. So what we need to be able to do at the end of this, or after we've been going through our practice, is we need to be able to define temperature, which we're going to do first, compare different temperatures of different materials, and also be able to convert between our degrees Celsius scale and our Kelvin temperature scale. So to start off, temperature is a measure of the average kinetic energy of the particles of a specific material or object. And if you remember from what you've been learning about, kinetic energy is motion. So really this is the average motion or the average speed of those particles. So a measure of how fast or slow the particles are moving, which means then that the faster they are, the higher the temperature is going to be. The slower they're moving, the lower the temperature is going to be. You need to be able to define this and know that temperature is a measure of average kinetic energy, because you're going to see that in a variety of questions, and we're going to expect you to be able to identify that. So the two big scales that we deal with in our chemistry course are the degrees Celsius scale and our Kelvin scale. So degrees Celsius, the most commonly one used throughout the world. We do use the Fahrenheit scale in the United States, but we're not going to be dealing in our course with that. The Celsius scale was set up by basically looking at the melting point of water, the boiling point of water. They set that to 0 and 100 respectively, and then made 100 divisions between the two. The Kelvin scale really relates well to our understanding of what temperature is measuring. So it's based on that molecular motion. So they set absolute 0 when all molecular motion stops, which we actually haven't been able to get to absolute 0 just yet, and then worked up from there. So there is no negative Kelvin temperature. Also, one little thing, Kelvin does not have a degree sign with it. You just write K, and you don't actually say degree Kelvin when you discuss it. So let's actually get into the last part of this objective, which is converting between these two scales. This is right on the back of your reference tables. So it's an equation that you are given. And we're just going to simply go through a couple of calculations and then just talk about how this can get applied a little bit further. So in this first one, the classroom has a temperature of 21 degrees Celsius. That's like about room temperature. What is the temperature of the classroom in Kelvin? So I'm going to start with my equation. Okay, our degrees Celsius is going to be plugged into where degrees Celsius is. So when I add those two together, okay, I get my 294 Kelvin. Okay. The trickier one seems to be number 2 when we're going from Kelvin to degrees Celsius, and it's usually because students don't write it out or they make a little add and subtracting error that I'll go over. So with this one, we have again our equation. In this case, I'm going to be putting 325 where Kelvin is, and then I'm going to plug in X for my degrees Celsius that I'm looking for. So from here, just be very careful. I want to get X by itself. So I'm going to subtract 273 from each side. Usually the error is that 325 gets subtracted from each side. Make sure you're looking at this plus 73 and then subtracting it. So that way the 273 goes away and we're left with X. And then when we do 325 divided by my 273, sorry, not divided, subtract, you get 52, and that was in degrees Celsius. Okay, so a simple equation to use. You just have to be careful with your math steps. The very last question is one a little bit closer to what you would see on a question where you got to apply the temperature scale conversion. You have one sample of water that has a temperature of 75, while a different has a temperature of 333 Kelvin, which has that higher average kinetic energy. Whenever you see average kinetic energy in a question, just replace it with temperature, because that's what it's defining. So we're really looking for which one has the higher temperature. Okay, these are in two different scales. We can't just compare them. We have to make sure they're in the same scale. I find it's easier to just convert the degrees Celsius one, because I'm just going to add 273 to it. So when I do 75 plus 273, I get 348 Kelvin. Now that they're in the same scale, now I can compare them. So which one actually has the highest average kinetic energy? That would be the sample of water at 75 degrees Celsius, which was at the 348 Kelvin. Okay, so make sure whenever you're comparing samples that are in different temperature scales to first convert them. So that is it. So you should know how to define temperature. You should know the two temperature scales that we use. And then you should also be able to use this formula so that you can convert between the two.